I drove all the way to the Netherlands to pick up this truck part, and in today's video I'm going to be fitting it. Now if you're wondering what this massive lump of metal in front of me is, it's a rear differential for a Mercedes Vario truck. And why have I got this part to fit? There's nothing wrong with the one on my van at the moment, other than the fact that it's incredibly slow. This truck was originally a horse box, and horse boxes are designed to carry very heavy loads at a low speed. First gear. Second. Third. In third gear, we're doing 25 miles an hour. Let's drop it to fourth. At the top of the green in fourth, we're doing 40. Let's change to fifth. My foot is flat on the floor. And at the top of the green, 2,750 RPM. We're doing just over 50 miles an hour. Because I'm turning my truck into an expedition type camper, I wanted a much taller ratio diff, because right now you'll be sitting on the motorway at 50 miles an hour with the engine screaming, and it's just not a pleasant experience. You've got people waiting to overtake you, cutting you up, and yeah, it's a nightmare to drive. But once I've installed this, it should give us an extra 20 miles an hour, I reckon, at the top of the rev band. So instead of sitting at 50 miles an hour at the top of the rev band, it will be 70 miles an hour, which will be much more comfortable for driving in Europe on those long, smooth, open roads. The engine it's got on this truck is the OM602, the 2.9 litre turbo diesel engine. It's got about 120 horsepower, so that's plenty for this application and what I'm planning to do with it. The only thing that's going to read off is a speedo, but I'm going to get around that by having a sat nav maybe, or one of those CarPlay units set up in there so I can see an accurate GPS readout for how fast I'm going. And then we'll have a look to see if we can potentially change the speedo cogs so that it reads accurately. To get this diff ready for refit, I'm first of all going to give it a thorough clean. Right, that's zeroed. Let's roll the diff on, and I'm just balancing that there. That's showing 85 to 90 kilograms. Wow, oh my God. Oh. That's heavy. I got this large plastic tray from Amazon, and I've put my diff in that so that any parts cleaner collects in the tray and it doesn't go all over the garage floor. I use a scraper to remove the old silicone from the flanges mating face, and we want this surface to be as smooth and clean as possible, ready for refit. A soft wire brush is good for cleaning up the mating faces, but the best thing to use is a bit of Scotch pad. I'll show you that in a little while, and that will bring it up like new. This diff has had a long journey back from the Netherlands to the UK, rolling around in the boot of my car. Because it's got this oily film on it, it's actually picked up lots of little specks of grit in between the teeth on the crown wheel, and so we need to clean all those little specks off so that it doesn't damage the internals of the differential. So using some parts cleaner, I work my way around the crown wheel, just cleaning out any dirt from inside the teeth. I then work on the bearings using a brush just to clean out any dirt from inside there. I spray it up with some carb cleaner I'm actually using. It's pretty much the same as brake cleaner. A bit of WD-40, anything that's going to get that dirt out of the bearings. And then you can see it gathering in the tray at the bottom, so it's not going to contaminate the diff again once it's been removed. This is the Scotch pad I was talking about. Just look how it cleans up the mating faces. Perfectly smooth, perfectly clean, ready for a new gasket. Now I don't know about you, but I love a good before and after. Just check out how dirty and greasy this differential was before. We've given it a thorough clean inside and out, making sure we've got rid of every speck of dirt. And would you look at that? Quality German engineering, perfectly clean, ready to be installed on my truck. I can't wait to get this in, but first of all, I've got to get the old one out. Not an easy task considering it weighs around 90 kilograms and I'm doing it out on the road. I tend to always park like this with my wheels facing into the curb, and I do this so that the curb acts like a chock just in case the handbrake fails. We're also going to be disconnecting the prop shaft so it won't have the gearbox holding the vehicle stationary, so it might be worth chocking all the wheels. The first job is to remove the prop shaft, so I start by reference marking the prop shaft flange to the diff flange, using my pin punching hammer just to put a dot on each one, and also my paint pen just to mark across it. That way when we come to refit it, we can realign the flanges, keeping the prop shaft balanced. These bolts are going to be very tight, so I soak them in penetrating fluid. A bit of plus gas is good for this. I couldn't get a socket on my nuts in this case, and so I manually shocked them using my punch and hammer just to break free the rust. To get in that tight flange space, I use a 16mm crowfoot spanner attachment on my breaker bar and then loosen the nuts off one by one. It is quite satisfying when you manage to loosen your nuts off in a nice tight flange space. It definitely helps if you lube them up first. You can see these bolts had some blue medium strength thread locker used on them, so when we come to refit it, let's make sure we put some on there. With the last bolt removed from the prop shaft flange, we can then disconnect the prop shaft from the rear diff. The flange on my differential at the moment has actually got 6 holes, whereas the replacement one's only got 4. They also look slightly different in length, the flange thickness is different, so I just have a quick measure up to make sure that they're interchangeable. I measure the length of the pinion shaft and the diameter, and we can only measure the splines once we've actually got the flanges off. So let's have a look. That's 60mm, and that one's also about 60mm. Perfect. So the flanges should swap over. Let's get the fluid drained out the diff. The longer we can leave it draining, the better, because it means it will be less messy when we come to remove the differential unit. I would typically say make sure you remove the fill cap first before removing the drain plug. However, we're taking the unit out and this has just got a rubber bung on the back of the diff, so it's not such an issue in this case. But if you've got a screw type fill plug, make sure you can remove that first before you drain the oil. After years of struggling with breaker bars and hand wrenches, I finally bit the bullet and got myself an impact wrench. This was under £100 from Amazon, believe it or not, and it's got 1,200 Newton meters of torque. Well, the manufacturer claims it produces that. This comes with 2 20-volt lithium-ion batteries, 1-year warranty, and it even comes with a selection of impact sockets. So I'm quite excited to try this out, and we'll see in this video whether it's any good. It's made by a company called Alloy Man. Never heard of them before. It comes in this nice hard protective case. And like I say, we've got a selection of impact sockets here. So all of the common wheel nut sizes. Even if you just want to use this to spin your wheels off, ideal, isn't it? 2 20-volt batteries, charger. Just look at the quality of this for under £100. Brushless DC motor, 1/2-inch drive, battery charge indicator on there, and then we've got speed settings here: low, medium, high. It's not too heavy, I like it. And there's the instruction manual, work light. Our differential unit transfers power to the wheels via the half shafts. In order to remove the diff, we need to make sure that the half shafts are clear of the diff unit so that we can withdraw it. Out comes our trusty paint pen. I reference mark the half shaft flange in relation to the hub, and I also label them up left and right just so we don't get them mixed up. And that's going to be really useful when we come to put this back together, so hopefully we don't get any leaks. It's time to pull out the big guns. Can it do it? Oh, light work of that, not bad. It's worth having a rag handy just to catch the excess oil out of the hubs, and then you can withdraw the half shafts. I'll clean up the flanges properly later, but for now let's just wipe up any excess oil, and then I'm going to plug it with some blue roll just to stop any animals crawling inside. It also stops any dirt from getting in there, and we'll do the same on the other side. I won't cut this bit out just so you can see how good this impact wrench is for the money. And that's the other half shaft removed, so I just plug that side up as well, and I put some bags over the hubs just to stop any moisture from getting in there, as I'll be working on this over a few days. The next step will be to remove the differential unit. However, before I do that, I want to give the axle a quick clean up just to remove any loose dirt so that we don't transfer it to the inside of the axle. And in true Turner's Workshop fashion, I got a little bit carried away. But if something's worth doing, it's worth doing properly. Using a selection of wire brushes, I went about removing the underseal from the rear axle in preparation for painting it. If I'd have known how difficult it would be to remove all of this underseal, I probably would have just left it. And looking at the condition of the axle underneath that underseal, it's actually pretty good. There's a tiny speck of rust on there, so using my wire brushes, I just scratched off as much of that rust as possible, ready to paint it with my rust converter. I use Vactan rust converter. I've been using this stuff for years. I used it especially on my old transit van, and it works quite well. So you just paint that on any rusty areas and it turns into a black paintable substance, and then I'll be applying my chassis paint over the top of that once it's dried. With my rusty bits painted up, I started prepping for removing the diff. In order to remove it safely, I needed to make sure that it would be supported underneath it. 90 kilos of German steel isn't very easy to move, especially when it's an awkward shape. So I screwed together a few blocks of wood I had lying around and fixed them to my transmission jack, and that way it will make it a more linear shape so it's easier to move around. I also glue some rubber strips on my block of wood and on the edge of the transmission jack just to stop the differential unit from sliding around. This rubber strip here is for the lip, and then this one is for this under here. Look at that. It does work, however the weight's right over here, and so if I lift this end up, you can see it just wants to topple over. To get over this, I make myself up a couple of studs, and this is going to help us line it up as well. I couldn't just use standard M12 studding because the thread pitch is different. In my axle, the holes have got a thread pitch of 1.5 and a standard M12 stud is 1.75. So to get around this, I just welded a length of normal M12 studding onto a couple of bolts that had the correct thread pitch. If there's slag, then drag. I do love a bit of stick welding. It's certainly not going to be pretty, but at least it'll be nice and strong. Well, hopefully strong enough anyway. With my couple of studs made up, let's move on to removing the diff. I start by disconnecting the vent pipe from the top, and I just tuck that out of the way. I use an 18mm impact socket. I just give it a tap onto the bolts to make sure it's seated nicely, and then I use my nice new impact to whiz the bolts out. Let's cable tie that brake pipe out of the way. Strategically, I've placed my long studs in the top bolt holes on the diff so I can slide the unit out, and a couple of bolts just loosely in there so it doesn't fall out on me. I then slide my transmission jack underneath the diff unit, and I had to use another little block of wood in there just to pack it out, and then I strapped it down really tight onto my transmission jack. And it's the moment of truth, time to remove the diff. Let's put the gloves on, this means business. And I use a crowbar to break the seal between the axle and the differential unit. And once I could feel that it was safely held by my transmission jack, I removed the two bolts that I'd put in the top there, And realistically, the studding was a bit overkill. I probably could have removed it at this point. As you'll see in a moment, it does get in the way a little bit. I then had to try and manoeuvre the diff underneath the chassis because it was a little bit too tall on the transmission jack. So I positioned a yoga mat just in case it fell, which of course it did, but fortunately that yoga mat there protected it from hitting the concrete. So I'll put a crash mat there. Once I'd cleared the diff unit from underneath the chassis, I then strapped it back up onto my transmission jack to wheel it into the garage. What's better than one diff? Well, two of course. Here I have the diff that I've just removed, and this is the one ready to go in. I just wanted to talk a little bit about the diff ratios and the differences between the two. So this has got a 40:7 diff ratio, which means it's got 40 teeth on the crown wheel and 7 on the pinion inside there. And this one has got a 40:11 diff ratio. So it's got 40 teeth on the crown wheel, the same number as this one. These crown wheels are actually identical, but it's got 11 teeth on the pinion in there. So more teeth on the pinion means the diff will go quicker. This has got a lot more torque though. So if I were to be carrying around really heavy loads at low speeds and I wanted it to drive like a tractor, I would keep this one in. I don't really want that for the application I'm using it for. I want a much faster, more comfortable drive, and so I'm putting this one in, which has got a diff ratio of 40 divided by 11, 3.64, 40 divided by 7, 5.71 on this one. Anyway, I won't bore you too much with that. There are two main adjustments that we need to have a look at on these diffs before we can install it. First one is backlash. Backlash is a little bit of play you have between the crown wheel and the pinion. If I rotate this diff, you can hear it. You can hear that clunking. That's a little bit of space between the crown wheel and the pinion gear. It's set up like that so it allows for lubrication, a nice film of oil to go between the crown wheel and the pinion to prevent wear. If you didn't have that play there, it would heat up and you'd get a diff whining sound more than likely. And if it was too loose, then you'd have too much clunking and it would damage the pinion and crown wheel. The gears would get worn down. So it's set up from factory, we don't have to adjust that. If you had a rear mounted differential and you had to take apart these components here, it would need to be set back up properly using a dial indicator and specialist tools. So I'd probably take it to an axle specialist if that needed doing. But because we've got a front mounted differential, we don't have to adjust any of that. This should be a straightforward swap. However, I do need to change the flanges over because this one's only got 4 bolt holes, whereas this one's got 6. I'm obviously going to use a 6 bolt hole one so it matches up with my prop shaft. The only thing we need to pay careful attention to is the bearing preload. So when these flanges are installed, the pinion nut is done up to a certain bearing preload, which is a force that's put on the bearings when they're installed. And we need to make sure that when we swap these flanges over, we set it up to the same bearing preload. So I need to measure it first, and to measure the bearing preload, I'm going to use this tool here, which is a bearing preload measuring tool. My socket doesn't really fit on here very well because the flange gets in the way, so I'm just going to grind a bit off of the edge. It's okay on this one because the flange is different. To make the socket fit inside the flange, I had to grind off the end of it just to make it a little bit smaller in diameter so it'd fit inside the flange. It didn't take too long just to take the lip off. I give my flange a quick clean up just to get rid of any loose rust, and then I put some reference marks on my pinion nuts and flanges. This is a good trick to make sure that your bearing preload stays the same. If the nut's in the same position when you reinstall it, then your bearing preload shouldn't change. However, I'm going to be replacing the pinion nut. I'm also going to put a new pinion seal on, and I'm swapping the flanges. So to make sure that that bearing preload stays the same, I want to measure it. So I'm now going to show you how you can measure it. So I put that on there, and then I'm going to gradually increase the force on the pinion nut until it starts rotating. So there's 2 Newton meters there, 2.5, about 3, and it starts rotating. I'm going to measure the bearing preload on this set now. 1, 2, 3, 4. 4 Newton meters, and it starts to rotate. It's got a little locking tab on here, so first of all I need to try and chisel that up. This approach of trying to hammer the little tab upwards turned out to be quite difficult. I just couldn't get the right angle to tap the tab upwards, so I used all kinds of different sized chisels, punches, anything I could find basically, just to try and unlock that tab. But I found a much better method on the other diff, so I'll show you that in a little while. Now I know for a fact that that nut's going to be on there very tight, so I use an old piece of steel I had lying around to make up a flange or pulley holding tool. Whatever you want to call it. On the other end of this piece of steel is actually the pulley holding tool that I used for my old transit van, so now it's a multi-purpose tool. So with our pulley locking tool made up, I just screw a couple of bolts in there to hold the flange in place, and then we can really put this impact wrench to the test. The impact wrench has got a 1/2 inch drive, whereas the socket I'm using is actually 3/4, so I had to use an adapter there, and after a good few minutes of rattling away, it wasn't touching this nut. Okay, so what we're going to do now, we need to get this nut off. Let's try and hammer that tab out of the way a little bit more, just in case it is still locking the nut. And you probably see people use gas torches at this point to try and heat the nut up to expand it, so that you've got a better chance of undoing it. I'm going to try and avoid heat in this case, because it does actually disturb other components when you heat things up. And I'm not having this diff rebuilt because it was off of a fairly low mileage truck anyway. So I get my breaker bar out just to see if I can loosen it off with that, but it wasn't having any of it. So I get my hammer out and tap the socket while still applying a large amount of force onto the nut, but still no luck. So I get the impact wrench out again just to see if any of that's loosened it off a little bit, and eventually the nut starts to move. Looks like it may have moved a touch. It did get there in the end. Quite impressive, really. Yeah, you're not really selling it to us, Ollie. In all fairness, that nut was done up super tight, so any other bolts in this job I don't think it will struggle with, but that was going to be a challenge for any impact. 2 turns. Another tip for making sure that bearing preload stays the same is counting how many turns it takes to get your pinion nut off using the reference marks. 11 turns. I may or may not need a bearing puller to get this flange off. We will see. And then when you come to reinstall the nut, you can count on the same number of turns, and then it should be close to the bearing preload you're looking for. Oh, no, I don't. That's one flange off. Let's get the flange off of the other diff so we can swap them over. And as promised, this is a much easier method for removing that locking tab on the pinion nut. I get my Dremel tool with a small cutting wheel and then just cut that little section of the pinion nut out. So much easier than struggling with the punch and hammer. And I think using this method is a much cleaner approach as well. The nut came off much easier on this diff. I didn't even have to use a locking tool. 12, 13. The flange didn't come off as easy on this one, so I had to use this bearing puller just to get the flange off of there. But once it got going, I just tapped it off the rest of the way using my hammer. I take the flange that I won't be using and just slide it back on the shaft of the old diff, and I'll put that to one side as I'll be cleaning it up and selling it later. So let me know if you're in the market for a Vario diff with a low ratio. This is the one we want. So using a piece of that fine Scotch pad, I just clean up the surface where the seal runs and just make sure that it's nice and smooth, and then also get rid of any rusty bits off of the flange face. We can then go about removing the old seal, as I'm also going to be replacing that. I'd seen this method online for removing old seals, where you drive a screw into your old seal and then use a claw hammer to try and pull it out. It didn't work with a smaller screw, so then I tried it with a larger screw, being a larger seal, but it still didn't work with that either. I'd say this method for removing seals would be much better on newer, much smaller seals, not so much on large truck seals like this that have been in there for 27 odd years. And so I use my hammer and punch to try and drive the seal out at various points. Obviously you can get special tools for removing seals, but for the amount I'm going to be doing this kind of job, I just made do with what I had available to me. And eventually I managed to get it out anyway. With the old oil seal removed, I can wipe off the bearings just to clean them up a little bit, And then I use a little bit of my Scotch pad just to clean up the surface where the new oil seal will sit. If there's any surface corrosion or pitting on there, just make sure it's nice and smooth for your new seal. This is actually in really good condition, so I didn't have to spend too long cleaning this up. I then got a drop of WD-40 just to spray out the bearings, just in case any grit or dirt got in there while I was cleaning the surface off. With these metal type seals, they have to be installed dead square, or else you could end up deforming it and then it'll end up leaking. I just got a couple of blocks of wood, drilled a large hole in the middle for the pinion shaft to come through, and then I just chiseled out a recess in it so that we'd be hitting on the outer edge of the seal when installing it. Let's get our brand new oil seal out of the freezer. Yep, that's right, it's not a pizza, I wish it was. And I've put the oil seal in the freezer so it contracts, and then that way hopefully it will be easier to install in our differential. So let's get our oil seal out of the box. Look at that, quality L-ring German engineered oil seal. A little bit freezing, so let's work quickly. I get some multi-purpose grease and just spread that around the spring on the inner lip of the oil seal. That's to stick it in place so when we're installing it, hopefully it doesn't pop off. The outer edge of the oil seal slightly tapered to help us ease it into the orifice. So let's just line it up and let's put a little bit of oil around the edge of the seal just to lube it up, and that'll help ease it in as well. And then we can get our block of wood, our seal press, whatever you want to call it, and put that over the top of the seal. Using my hammer, I evenly tap around the edge of the seal, making sure that the seal goes into the orifice nice and square. It's certainly not worth rushing this part, because if you kink that seal, you'll have to get a new one, and they're not cheap. Mercedes actually wanted £100 for a new seal, so I took the part number, went online and found one for £35 on Autodoc, £45 including delivery. I'll take that. And I think L-Ring actually make the oil seals for Mercedes anyway, so they're identical parts. It just costs double, if not triple the price to have a little star stamped on it. And our new seal needs to sit flush with the seal carrier, so let's just make sure that it's flush all the way around the edge, which it looks to be. Before I install the flange, I just give it a quick spray paint with some zinc primer, and that's to stop it going rusty. I get my flange lined up on the shaft and then put a small amount of oil just around the surface that the seal runs on, and that's just to help ease it onto the new seal. I then take my brand new pinion nut and install it on the shaft. I took a trip over to Rossett's to pick up this new pinion nut, and I asked them for the torque specification. And would they give it to me? Of course not, that's top secret information. After lots and lots of searching around, I think I've finally managed to find a decent workshop manual for the Mercedes Vario trucks. I got this access through a company called eManuals Online, and this is the WIS system, the workshop information system, the same one that Mercedes use for carrying out service and repairs in their workshops. Once I put my VIN number in, I could search around for all the different torque specifications. You can see here we've got the differential unit, and the collar nut of drive flange is 500 Newton meters. You can also get access to all of the wiring diagrams, which is very handy, so I'll be using that in my upcoming videos to try and figure out what's wrong with my compressor circuit. And we can also do smart searches to search specific components. There's loads and loads of information on there. So if you'd like to get your own copy, I'll put a link in the description below to where you can pick one up, and if you use code TurnersWorkshop22 at checkout, you'll get 22% off. In order to do up this pinion nut really tight, I could use my rattle gun, but it's not very accurate, so I've actually got this torque wrench which goes up to 500 Newton meters. That'll be testing this tool out at the top of its capacity, so let's see if it holds up. Put our socket on there. It's a 3/4 inch drive on this one. That's 320 Newton meters there. Let me just check to make sure that the pinion still rotates all right. That's perfect. 400. Come on. There we go. The torque wrench is set to 500 Newton meters now. I've just got to try and get it to click. Holy shit. Well, I just sheared the bolt off, so I'm happy that's tight enough. Let's check our bearing preload. Because this is a shim diff, it's got solid shims in here, not a crush sleeve, so The bearing preload should remain the same, even though we've put a massive amount of torque on that nut. So let me just check it. Yeah. Just over 4, perfect. Right, let's lock our pinion nut in place. Now it's torqued to spec. And here's a close-up of our new pinion nut mechanically locked in place at 500 Newton meters. I checked the bearing preload one last time just to make sure that it's remained the same, which it has, and then I'm happy that this can be installed back on the truck. I've been banging on about bearing preload this whole video, but I just did this nut up to 500 Newton meters and that was it. The bearing preload remained the same. So why did I have to count the number of turns it took to take the nut off and stress about reference marks and all that? Well, that's because differentials are built differently, and depending on whether you've got solid shims inside your differential or you have a crush sleeve will determine whether you do your pinion nut up to a set torque specification or you do it up to the set bearing preload, which you measured before you took your flange off. It's worth doing a little bit of research first to check whether you've got a shim type diff or whether you've got a crush sleeve in there. Because if you've got a shimmed type diff, you've got a pack of solid shims in here between the two bearings, and as you do this nut up you can't compress those shims anymore. They're solid shims, so once that's done up, it's done up to a set bearing preload which won't change. However, if you've got a crush sleeve in there, it's compressible and your bearing preload is determined by how much that sleeve's crushed down. So when we counted the number of turns it took to take this nut off and we reference marked the nut, if we had a crush sleeve type in here and we installed this, we'd need to check periodically as we're doing the nut up that we're achieving the same bearing preload as it was when we took it off. Because if we go too tight with that nut, the crush sleeve will compress too much, the bearing pack will squeeze together, putting too much bearing preload on it, and then when we go to install it on the truck, it will have too much resistance, the bearings will overheat, and then the whole diff will have to be stripped apart. So it's really important, if you've got a differential with a crush sleeve in it, to make sure that your bearing preload remains the same throughout the job. I put a poll on my Instagram account asking you guys whether you'd prefer to see this in 2 shorter videos or 1 long one, and the majority of you said you'd prefer 2 shorter ones. So that's what I'm going to do. I'm going to finish this video here. I hope you've enjoyed watching it so far. If you have, please don't forget to give it a thumbs up. Consider subscribing to the channel if you're not already subscribed, and if you hit that alarm bell and set notifications to all, you'll be notified when I post new videos. Join me next week where we'll be installing the differential unit. I'll give the axle a good clean up and I will paint it. I've already painted it, but I'll release the video next week and then we'll take it for a test drive and see if it actually makes a big difference. I'm really hoping it does because I've put a lot of work into this video. Links will be in the description below to any of the parts or tools I've used in these videos if you see anything you like. If you buy it through the links, you'll also be supporting the channel, so I'd really appreciate that. You don't pay any more for the products, it just means I get a small kickback off of any sales, which I can use to help fund future videos. I've got loads of videos planned for the channel, it just takes me quite a while to make them because I do work full time as well, so please be patient with me and we will get there in the end. Just broken a tool. Holy shit. We also needed a specific, oh shit. Now, careful, that's a bit slippy that.